Right, welcome to computing or computer science. This is abstraction and automation, problem solving, etc. So they sound like big words, but they're really not. So first part of this topic is solving. So obviously when it's solving its problems. So problem solving is a method which involves going from an issue to a solution while following a bunch of steps. For example, in say exams, you would be given a series of statements which would help you up that steps to be able to get to the final solution. So these problem solving methods are normally written in ways so they are step by step. So they act kind of like an algorithm. So it would always like either end into one thing or go into something else. And that's how it works in a way. So say we were to see the answer or the question, Alice, Bob and Charlie are each wearing a hat, but they cannot see their own hat, and they can see the others' hats. They are told that each of their hats is either green or yellow, and they don't all have the same colour hat. Charlie then says, I know my hat is yellow. What colour is Bob's hat? Okay then, so how we do this is, say, this is a problem solving where this is Alice, this is Bob, and this is Charlie, and they're all wearing hats obviously. So Bob has already said he knows that his hat is yellow. So we have already eliminated Bob and yellow from the formula. So they can see each other's hats, but they do not know what their own hat is. So the basic solution would be Charlie can see both Alice and Bob's hats. For Charlie to be able to say that she knows the colour of her hat, Alice and Bob must have the same colour hats. Because Charlie has been told it is not possible for all three to have the same colour. So that was a simple problem solving starter in a way that shows these two both have a green hat. So algorithms. Algorithms are a sequence of steps used to be able to find a solution. Algorithms always terminate and never go on forever. They always have like an end goal in a way. These can be written in any programming language, like although in exams pseudocode is preferred, any program language can run, but pseudocode allows like different things to be able to be measured. So when you do something in pseudocode, it has to be made very clear, very simple for the average person to be able to understand, so they can look at this and they can be like, okay, so get user in fun. If user in equals fun out good. So obviously that's like not very good pseudocode, but it's the basic premise. So literally just gets the user input fun. If the user input is fun, output's good. Anyone can follow that along. So that is the basic premise of pseudocode. Make it so like people that don't know code can be able to process things. So other things such as sequences in pseudocode. Sequences are given to instructions that follow on from one another. So that is the first instruction, it goes into a second, then into a third, etc. So this would be a simple thing such as counter equals 1, counter plus equals 1, while counter not equals to print lol. So in this case, each time the loop runs, it would just increase by 1 once. So this would not work and would not be a good sequence. But if you were to move the counter here, that would then be a sequence because it has a false termination of the code. Simple. So selection in pseudocode. So selection. This is the process of choosing an action based on another action. This would be stuff such as if statements. So that would be like, say, if something happens, then something else happens. So in this case, it would be, like, say in a flowchart, it'd be that, and that'd be the decision box, and it would go either that way or that way based on, say, an input of y or n. And that would be the basic premise of selection. So iteration in pseudocode. Iteration is basically the process of getting a value and then putting that value into a formula and then getting that, changing that formula to make it into something else and putting that answer back in. So I know that may or may not be confusing, but it is the process of repeating an operation while using a previous input in a way. This would also be a loop, so you can use a for loop or a while loop here, but that was just a basic of iteration. Simple. So abstraction, you may have heard of this in stuff like biology or physics, but abstraction would be the process of getting rid of unnecessary details from a problem. So in some cases that would be like, say, when it's Saturday, and it's cold, what's 2 plus 2? So abstraction would be the ability to get rid of that, and it would just keep the what's 2 plus 2, thus making it a lot easier for everyone to be able to understand and use up less data overall. So information hiding. This would be the process of hiding details which are not essential. So if it's not required at that very moment, it will be hidden somewhere until it is required. Is kind of like getting rid of loose weight and or data, so you have more space to do other things. So now procedural abstraction. This would mean it would break down something big into small things, which would be things which you could use over and over again to be able to find the solution of this big thing. So the actual values are used in computation are abstracted anyway, and the computation method is activated. So obviously, to be able to get all of this, you would repeat this over and over again until it were to work. And now functional abstraction. Functional abstraction is the process of leaving us with a function. It would literally just mean that it would get rid of info to be able to leave us with just a function and or procedure that we would need. Data abstraction. So this is now data abstraction, not just abstraction, which would be specific details on how data is actually abstracted. So it would actually take into regards how it is actually being abstracted, and then would be able to make new place for previously defined structures. So now the final three. Decomposition. This is when a program is divided into a series of small programs, and these small programs have a easy fix, thus eventually making the whole program a fix and fulfilling decomposition. So now, composition. This is the process of combining functions to make a bigger system. This would be used to abstract data types, so that means you can get rid of details. So the process of decomposition would be to be able to make a big thing small to be able to make it easier to solve, and the process of composition would be the process of making small things big to be able to abstract it and get rid of unnecessary details. And now finally, automation. This would be the process of putting abstraction into real world scenarios, and this would be done by making an algorithm which would be later used in code which would actually help real world phenomena. So that is basically it. That is the entire topic of abstraction and automation. Nice, I guess. Sub, please, maybe, please.